We want to see now how we're going to find the tangents and normals to the curve when we're using the parametric form. So what we want to do is we want to keep considering the idea that we've got the point 2at at squared on the parabola x squared equals 4ay. Now, we've got our point, and remember how we find a tangent, we need to have a point and we need to have a gradient. Now, how do we find the gradient? Well, obviously, seeing we've got the equation, the parabola there, we need to find the derivative. And so we can find the derivative function, the gradient function, and then be able to find the gradient there. So our parameter here is obviously t, so 2at at squared. So when y is equal to x squared on 4a, because we've rearranged it, we get our derivative. We get 2x on 4a, because we're driving with respect to x, not with a, because remember a is a constant. And that gives us x on 2a. Now at the point 2at on 2a, or what's at the point, sorry, where x is equal to 2at, we can divide that by 2a, we get our gradient of t. So the gradient of the tangent at that point, 2at at squared, is equal to t. So the equation of the tangent then would be y minus at squared, because we're using the y value, equals to t outside of x minus 2at. So we have our expansion, and then we collect everything on the left hand side, and there's our equation of our tangent, tx minus y minus at squared. So if you might be noticing that the actual parametric number there, t, that we have in here, is the actual gradient of the tangent as well. So we can use that idea as we go through. If so, we'll see in the next question here, if we're trying this one, where we've got 6t, 3t squared, we'll firstly show that it lies on that parabola. Substitute it in. 6t all squared, 12 minus 3t squared, 12 times minus 3t squared. And so we get 36. So we get 36t squared equals 36t squared. So it does lie on that parabola. So we should add a minus there. So we get the left-hand side is equal to minus 1. Find the coordinates of the point where t is equal to minus 2. So when we get that, well, when t is equal to minus 2, obviously, from where we're seeing up here, then we're seeing that we get the point minus 12 minus 12. So there's our point that we get. Minus 12 minus 12 is on the parabola. It's obviously concave down parabola. Now, find the equation of the tangent of the point to the parabola at t. So there's our point. Our gradient, we can do it two ways. We can realise that, well, if t is equal to minus 2, then our gradient's going to be minus 2. Or we can still show that we'll find the derivative of this function. So put y in terms of x, then find the derivative of the function, and then substitute minus 12 in, and we get gradient being equal to minus 2. So if we have that situation, we're going to get that minus 2. So we substitute our point, our gradient in, we're going to get our equation of 2x plus y plus 36 is equal to 0. So there you can see that, like, the idea that where t is equal to minus 2, it gives us that point, and also gives us the same value as the gradient. So we can that will work all the time. Equation of the normal. Now remember, taking the equation of the normal, we're going to take the negative reciprocal. So we do our same process as we did before. Get our gradient of our tangent, and then the gradient of the normal is minus 1 over t. So from that, the equation of the normal would be the y minus at squared equals the minus 1 over t, x minus 2at. And then multiply through by the t, multiply through by the negative on the right hand side. Collect our terms if we want to put it that way. But oftentimes you'll see it written in that form. So x plus ty equals at cubed plus 2at. So we have that. That's how we can write our normal, although it doesn't really matter if you write it like that. But just be wary that you'll see it in that form. All the x's and y's on one side and all the numbers on the other. So we're seeing how we find the equation of the normal to x squared equals 16y at that point. So again, we can get our gradient and get our gradient of our normal in that way. Or if we realise that, well, if it's 8t, the tangent would be t, and we proved that. And the normal would be minus 1 over t, and then we can start to sub it in with our point and get our gradient in that form either way. So if you can remember the actual equation, then that could work too. I'm not that fussed on remembering the formula and remembering the actual gradient equation of the tangent and the normal. That's making it a little bit hard. And if the question asks you to prove it, then you can't just quote the formula anyway. So it's easier to remember how to get it. You get your gradient, get your point, and be able to substitute it in. So we'll see more questions about these in class, but here, try and get a handle on how we actually find the gradient of the tangent and the normal, and be able to substitute it in to get our equation of both of those.